Okay, today, ladies and gentlemen, we are going to be doing Notes 4, which is the first of our application problems and our word problems. So we can really focus in on how do we apply quadratics. So to start off with, I want to just kind of briefly touch on double roots. We haven't really talked about, and I just want to expose you guys to it, because you might see this with applications, but you'll especially see this a lot when you get into Algebra 2. So if you recall when we started, or when we were working with factoring, when we did that special case factoring, sometimes you ended up with factors that were identical. You had two factors that looked exactly the same. And so what we do is we would take those two factors and we write them as the same factor squared. Well, that also can affect your graph. Okay, yeah, last notes we learned how to do it in intercept form, which is where we use that factored form to do our intercepts. Okay, but if we factor and we get the same number, then we only have one x-intercept. Okay, so that changes how we do things. And it means it's only going to cross the graph once. So we're going to take a look in a little bit at what that looks like. So the vertex of the parabola is going to be the x-intercept. That's what the double root means. It's going to be the x-intercept. So there's only one x-intercept. It makes sense. Let's take a look at graphing some of these. So let's take a look at number 1. So I'm going to use the standard form way of graphing. If you want to use a different form, you can. If you want to factor it and use intercept, that's fine. But I'm going to use standard form since it's already in standard form. So x is equal to the opposite of b over 2a. So the opposite of b over 2 is equal to -2. So we know that the x-coordinate of our vertex is at -2. So now I'm going to plug that back in to see what my y is going to be equal to. -2 squared is 4. -2 times 4 is -8. And then we're adding 4. Well, 4 plus the -8 plus 4 is going to give us 0. So my vertex is actually at the point over -2 up 0. Next thing, I know that my axis of symmetry goes right down the middle of the vertex. My y-intercept is at 4. So I'm going to take that y-intercept and I'm going to reflect it over the axis of symmetry. So I'm going to go over 1, 2 to the axis of symmetry, go over 1, 2 more. And then once we have our 3 points, we can graph our parabola. So that is what a double root looks like. Okay, it's just going to touch the the x-axis. So I want you to try number 2. You might get a double root, you might not. Make a note to yourself. Is what you have a double root or not? Okay, so go ahead and pause the video and try that. All right, so let's talk about when we get into these word problems, how we can solve them. So what I like to do is I like to ask myself 3 questions when I'm reading through word problems. First question, what do I know? Second question, what do I want to know? Third question, what part of the quadratic is going to tell me what I want to know? Is it the y-intercept? Is it the vertex? Is it the axis of symmetry? What part of a parabola will give me the answer that I want? So those are the 3 questions that I look through as I'm going through these. So first of all, let's take a look at this first one. So we're talking about a motocross. The path that a motocross dirt bike rider follows during a jump is given by y equals -0.4x squared plus 4x plus 10, where x is the horizontal distance in feet from the jump at the edge of the ramp, and y is the height in feet. What is the maximum height of the rider during the jump? What do I know? What do I need to know? How am I going to get it? Okay, so first of all, I know that this graph right here, this is my motocross jumper. We're going off the jump, we're going up into the air, and eventually gravity takes over and we're going to come back down. I know that. What do I need to know? I need to know its maximum height. Note that word, maximum. If I need the maximum height, I'm going to need a vertex that is the maximum. Well, neatly enough, we have a graph on here. It's already graphed for us. So I want to find the maximum of my parabola, which is here. So then this is the maximum height of the motocross rider. So now I just look over at the side, and the maximum height is at 20 feet. That wasn't too difficult. What do I know? What do I need to know? What part of the quadratic will tell me it? So let's take a look at ones where we actually have to do some mathematical solving ourselves. Let's take a look at this minimum cost one. Well, we're given a quadratic. So go ahead and pause the video, take a chance to just kind of read through this problem. So we're given a quadratic. Okay, so we're saying that y is our total cost and x is the number of cakes prepared. So first they just ask us to find the vertex and the axis of symmetry. All right, done. I can do that. I know how to do that. The axis of symmetry, or the x-coordinate of the vertex, is x is equal to opposite of b over 2a. So I get 12 over 2 times 0.5. Okay, 2 times 0.5 is just 1. So I get 12 for my x-coordinate of my vertex. Now I need to find my y-coordinate of my vertex. So y is equal to 0.5 times 12 squared minus 12 times 12 plus 150. So when you enter that into your calculator, remember, careful how you enter it in. Use those parentheses. It's to your advantage. When you enter that in, you get 78. So my vertex then is at the point 12, 78. So what is the minimum cost? So we're not going to draw our parabola, but we're smart people. We don't need to draw it to figure this out. Okay, we know that if a is less than 1, we have a maximum. If a is greater than 1, or sorry, if a is, yes, if a is less than 1, we have a maximum. If a is greater than 0, we have a minimum. Sorry, if a is less than 0. So right here we look, and a is greater than 0. So we have a minimum for our parabola. So this parabola represents a minimum. Well, the minimum of any parabola is the vertex. So what is the minimum cost? The minimum cost is going to be the y-coordinate of our vertex. So if you're having problems visualizing, here's our vertex right here. Here's our parabola with our vertex. So we don't need to go through and mathematically solve this. We know our a is greater than 0, so we know we have a minimum on our parabola. The minimum is always the vertex. So that right there is our minimum. So the minimum cost is $78. We know that because y represents cost and x is the number of cakes. So how many cakes should be prepared to yield the minimum? Well, we need to prepare 12 cakes. And that comes from the x-coordinate of our vertex. All right, let's take a look at the next one. So this one, we have to set things up. We have to actually write a quadratic formula. So I'm going to teach you guys a set method for doing this. So a sports store sells about 50 mountain bikes per month and at a price of $220 each. For each $20 decrease in price, there's 10 more bikes sold per month. So what do we know? Well, we know a lot of math mumbo jumbo. Okay, that's what we know. What do we need to know? Well, I need to know a quadratic to represent this situation. And also from that, I'm looking for the maximum revenue. So I need to know the vertex of that said quadratic. So here's how these get set up. We're going to make two parentheses. So it's going to start in intercept form. The first parenthesis I'm going to use to represent bikes. So anything pertaining to bikes is going to go in there. And then in my second parenthesis, I am going to put price. So I'm going to let x represent how many times I'm decreasing. And y is going to represent that maximum cost. So I start out, I'm selling about 50 bikes per month at a price of $220 each. For each $20 decrease in price, so that goes in my price category. So for every X decrease I do, it's going down 20. We're selling 10 more bikes. So for every decrease in price, we're adding 10 bikes. What I want you to do right now is pause the video. You have two options. You can use the box method or FOIL and get this into standard form. That is what I suggest. So I want you to do that right now. Option number 2 would be to just keep moving on and use the intercept form to find the vertex, but I suggest putting it in standard form. Pause the video, put it in standard form. When you're done, I'll put the standard form up there for you. So once you've gone through and multiplied this out using the box method, you set it up like this. You did 50 and 10x and 220 and negative 20x. Once you've done that, you've gotten your final quadratic to be this. Y equals negative 200x squared plus 1,200x plus 11,000. So that's our quadratic. What price produces the maximum revenue? Well, we need to figure out, first of all, how many times am I going to decrease the price? Then I need to figure out what is the maximum revenue. So that's just the vertex. The number of decreases is our x-coordinate. The maximum revenue is our y-coordinate. So let's start by calculating our x-coordinate. So we do the opposite of b over 2 times a. So we get 1,200 over negative 400, which gives us a positive 3 decreases. So we're going to decrease our price by $20 3 different times. Next thing we're going to do is calculate what our maximum revenue is going to be. So I'm going to take wherever I have an x, and I am going to plug in 3. So I'm saying I'm taking that decrease down 3. So then I'm going to simplify. When you plug this all into your calculator, please try and remember to use the parentheses. It's to your benefit. When you plug that all in, you get $14,000. So that is your maximum revenue. Let's take a look at this one. So we have digital cameras. Pause the video, read over the word problem. So we're going to set this up exactly like we did before. First of all, what do we know? Well, we know a bunch of math mumbo jumbo. What do we need to know? We need to know a quadratic. We don't have a quadratic. We also need to maximize monthly revenue, which means we need to find a maximum or a vertex. So I'm going to write my quadratic, then I'm going to find the vertex. Okay, so let me write my quadratic. So I'm going to have 2 parentheses, and then I am going to do, all right, we're starting with 70, so I have my camera parenthesis, and I have my price parenthesis. So I have 70 cameras per month at $320 each. For each $20 decrease in price, so for every decrease X, we're going down $20, about 5 more cameras are sold, so plus 5X. So again, as a side note, X is our number of decreases. So now, we're going to go ahead, pause the video, and put this in standard form. Okay. Once you get it in standard form, you get y is equal to a negative 100x squared plus 200x plus 22,400. So let's check. X is equal to opposite of b over 2 times a. So right now I'm going through and I'm figuring out that vertex. So when I do that, I get that x is only equal to 1. So we only want to do this once. So what does this mean? Well, think about it logically when you have a parabola. Okay? If I don't decrease it enough, not enough people are going to buy it. If I decrease it too much, I'm going to lose money because I still need to pay for the cameras themselves. So what I want you to do is take this one decrease, plug it into your original equation. Once you've done that, you will get the maximum revenue. So what is that maximum revenue when you plug in x is equal to 1? Last one, this is set up the exact same as the first two. I want you to set it up, put your answer in standard form, then solve it. Okay, give me that maximum revenue. You're looking for a maximum revenue. And it doesn't say it on here, but I want you to tell me what the maximum revenue is and how many decreases. So go through, set it up, put it in standard form, and find that vertex. Once you're done, remember to take your quiz.